another video. So I was checking my old videos out when I realized that I haven't teaching you guys a very concept of machine learning that you guys were supposed to know. So it's about decision trees and what all the pictures are in the file of decision trees do, because that's what I never learned about when I was started. So let's get started. I'll teach you guys step by step. You can pause the video, review, take notes anyway. And also, I'm sorry, today we were supposed to make a game, but yeah, I saw my video that I never teach. So if you search decision tree example, let it load. So if we go in here, machine learning. Okay, this is a good one. And no, these sites are not sponsoring me. Yeah, so let me just zoom in so you guys can see. Okay, so you can see Genie. So what Genie is basically, so this is about the iris flowers. So the iris flowers are basically a file that is already loaded into Python. So it has a 150 samples. It has three different types of what do you call it? Samples. So and we have spale height, spale width, petal height, and petal length, and width. And also we are now, so what it's loaded into Python. It has 150 samples, so 50 samples each. And yeah, so what Genies is basically how sure the machine is that the value Setosa is the first one. And also, the machine is not really sure that Versicolor is. So look, let me just show you the pictures. Setosa flower. So this Setosa flower kind of looks like this. This is Iris Setosa flower. We also have Iris, what is the Versicolor flower. It looks kind of similar, but the machine can find it out. And for Iris, what was the other name? Hold up, let me see. So the Virginica. Iris Virginica. So Versicolor and Iris Virginica kind of looks like the same thing. That's why the machine, so here, let me look. So you can see the machine thinks that Versicolor is also what is that one called? Virginica. So it's not really sure. So what we really need in the decision tree model is for the Genie to be 0. Because, oh my god, once the Genie is 0, that means that, so the model is 100% sure that that's first or second, or its age is 20 or anything that we have. Okay, so like this one, let me just load you the machine learning iris data set. So Let me see if they can show the data set. Data set. 3 algorithms. So this is the Spale and that's the Patel. Okay. So this is the file. You can see it's so you can see it's Spale length centimeters, Spale width. Let me just zoom in. Okay. So these are all the data sets that are in the data, right? Now let me zoom out. So that's basically what decision tree models are. So, and then now you can see at the end of the data, this is where it all ends. You can see that on the ones that have branches, the Gini is not 0. So the decision tree keeps on creating the branches to get an answer 0, Gini 0. You can see at the start, the Gini for this is 0, and then now this one is not 0. And then you go here for 0.4 and 0.16, and then you can see here the Gini is 0, so there's no branches. You can see here about this, and then you come here and this is Gini is 0, and this Gini is also 0. Okay, so there's no branches going out of here anymore. Same with these two, there's no branches going out. Same with these 3. The ones that have branches, that means the Gini is really unsure or does not know what the stuff is technically. So then the decision tree keeps on creating true, false, true, false, true, false, true, false, true, false, okay? Until the Gini gets 0. So the faster the Gini gets to 0, the better your model is at understanding it. This is called a supervised teaching. We supervise the model while it's learning. So the model does not learn if we teach the model dog, what a dog looks like, and we use decision tree, if I show a cat, it's not gonna know that's a cat. But if I use unsupervised learning and if I show it a cat, it's gonna find out, because the only thing that we're doing while we are teaching the dog is how it can learn, you know? So yeah, that's basically it for today's video. This was a little update about decision trees, what they do, and how they can help. So now a quick review is a decision tree has Gini. The Gini is about how sure the model is, right? And the higher the Gini is, that means the worse it is. That means the worst is the model that the model is worse at finding it out. So after each point, there is either 2 possibilities. One is really slim, and it's you don't get any Gini, it just goes for infinite. The other one is you get a clean cut 0 Gini. So yeah, that's basically it for this video. Thank you for watching. Please subscribe. It's free. Why not? Peace.